It's time for Maths with Mr. Thomas.
Hey, hey, hey! Here we go, Chapter 5, Lesson number 3, Binomial Theorem, which is all about expanding x plus y to the power of n. So let's look into that in a little more detail. Let's say we had x plus y to the power of 0. Kyle, what is that? Perfect, it's just 1. Anything to the power of 0 is 1. If we have x plus y to the power of 1, Amna, what's that? Brilliant, that is just going to be x plus y. X plus y squared you have been doing for years. You can multiply out the brackets. It gives you x squared plus 2xy plus y squared. We can work out x plus y cubed by multiplying this answer by another x plus y. We can work out x plus y to the power of 4 by multiplying this by another x plus y. And we can keep on going. These are the answers that we would get if we did that. Tell me something that you notice, Maria. Actually, give me 3 things. Perfect! The first thing that you're noticing is that on each row the powers of x descend from n to 0. So let's take this row here, x plus y to the power of 4. Notice the powers of x, you've got x to the power of 4, then x to the power of 3, x to the power of 2, x to the power of 1, and then x to the power of 0. But obviously x to the power of 0 is 1, so we don't bother writing that. You also notice that the powers of y ascend. They're going up from 0 to n. So you'd have y to the power of 0, y to the power of 1, y squared, y cubed, y to the power of 4. And also, the sum of the powers is always n. So here, x to the power of 4, if you add the powers, well, it's only the 4. You've also got y to the power of 0. But if you add them, then you get 4. Here you've got x to the power of 3 and y to the power of 1. 3 add 1 is 4. X squared, y squared, 2 add 2 is 4. So the sum of the powers is always n. What else do you notice? Think about the coefficients. Well, if you notice the coefficients here, well, we're starting off just with 1. On the next row of the coefficients, we've got 1x plus 1y. So we've got 1 and 1. On the next row, we've got 1x squared, 2xy, and 1y squared. So the coefficients, we've got 1, 2, and 1. On the next row, we've got 1, 3, a 3, and a 1. Do you notice any pattern? We've got a 1, a 4, a 6, a 4, and a 1. So that's the next row. And at the bottom here, coefficients, we've got 1 x to the power of 5, then we've got 5x to the power of 4y, and then a 10, then another 10, then a 5, then a 1. This here is known as dun, 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 Pascal's triangle, named after the famous mathematician Blaise Pascal. And to find an entry in Pascal's triangle, for example down here, what you do is you just add the 2 numbers above. So 1 add 2 would give you the 3. For this entry here, 2 add the 1 gives you 3. And we're starting off with a 1 just at the sides. So here you've got a 1, then 1 add 4 is 5. 4 add the 6 would give you the 10. 6 add 4 gives you this 10. 4 add 1 gives you the 5. And then we're finishing off with a 1. So to find any entry, you just add the 2 numbers diagonally above. This means that the next line will be, Ben, help us out. What's the next line going to be? Perfect. Well, we're starting off with 1, then we would do 1 add 5, which would give us 6. Then 5 add 10, which would give us 15. 10 add 10 is 20. 10 add 5 gives us 15. 5 add 1 is 6. And we're finishing off with a 1. Perfect. Notice the link though, the coefficients here when we're expanding x plus y to the power of something, x plus y to the power of n, the coefficients follow this pattern. Which means then that if we worked out x plus y to the power of 6, the coefficients would be, well, because the next line is 1, 6, 15, 20, 15, 6, 1, we would have x to the power of 6. So it's 1x to the power of 6. And remember, the x's would descend, the power descends from 6 all the way down to 0. So we would end up with the coefficients as 1 and 6, 15, 20, 15, 6, and 1. We would have a x to the power of 6, then x to the power of 5, x to the power of 4, 3, 2, 1, and 0. And the y would go y to the power of 0, then 1, then 2, then 3, then 4, then 5, then 6. The amazing thing is if we take that a little further, so this here is Pascal's triangle. We're starting off with, we're calling that row 0, then row 1, row 2, all the way down to row 7. If we take this a little further and we can link it into the last lesson. In the last lesson we were looking at binomial coefficients, and something that works out is we can express Pascal's triangle as binomial coefficients. So this entry here, 1, is the same as the binomial coefficient 0, choose 0. The next row with 1 and 1, well that is the same as 1, choose 0, and also 1, choose 1. With 1, 2, 1, again we can write those entries, the 1, the 2 and the 1, as binomial coefficients. We can write that as 2, choose 0, also 2, choose 1, and 2, choose 2. So 2, choose 0 is 1, 2, choose 1 is 2, and 2, choose 2 is 1. The next row as well with 1, 3, 3, 1. We can write that as 3, choose 0, then 3, choose 1, 3, choose 2, and then 3, choose 3. And the same with the next line as well. All of these entries can be written as binomial coefficients. Note when we are doing that, the binomial coefficients, let's say we've got n, choose r. Well, the n, the number at the top, is the row number of Pascal's triangle. And we are starting with row 0. So the next row would be row 5, so the numbers at the top would all be 5. The number at the bottom, how do we get that? Well, that's the term number going from 0, and it starts at the left, goes to the right, starting from 0. So you would have 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. And those entries, if you work them out, if you worked out the binomial coefficient for 5, 0, you would get 1. 5, choose 1 is 5, 5, choose 2 is 10, and right the way along. This means then that we can use binomial coefficients, really the entries for Pascal's triangle, to expand x plus y to the power of n. Doing that, well, we would have n choose 0. Remember, n is going to be the row number, and we are starting at the left with 0. The x's would start with n and then go down all the way to 0, so we would have an x to the power of n. The y starts at 0, so it would be y to the power of 0, and that would increase. We then move on to the next term, which will then be row n, but would be one term in, so it would be n1. Again, the x term would start with n, it would go down, so would that be then x to the power of n take away 1. The y started off with y to the power of 0, which is why it isn't here, and then you would have a y to the power of 1. Then after that, you would have an n choose 2, and you would have an x again going down another one, so it would be x to the power of n take away 2. Y though would be to the power of the number just here, so it would be y to the power of 2. Really, that pattern you will follow until you get down to nr, x to the power of, well, to work that out, all you do is you would do n take away 0, then you do n take away 1, then n take away 2. So if we have an r, it's just n take away r. The y, notice, is to the power of 0, then we've got a 1, so it's to the power of 1. It's the 2, so it's to the power of 2. If it's r, it's to the power of r. And we would keep on going until we get down to n choose n. So if n was 6, we'd finish off with 6 choose 6. X would be at the power of 0 when you finish that off, and y would be at the power of whatever's at the bottom, which is n. A shorter way of writing this is to say it's just going to be the sum of, well, we're starting with r as 0, we're going all the way up to n, and we have n choose r, x to the power of n take away r, and y to the power of r. Notice here, similar to what we had just in the first page, the powers of x descend from n to 0, the powers of y ascend from 0 to n, and the sum of the powers is always n in each of the terms. To find a general term then, it is sometimes best to write this down if you are expanding x plus y to the power of n. To get one of the entries, what you would do is you would take nr, it's x to the power of n minus r, y to the power of r. And notice when n is going to be low, so if you're asked to expand something plus something to the power of 4, or to the power of 5, or to the power of 6, or 3, you would just use Pascal's triangle. If it's anything bigger, if you had x plus y to the power of 18, you would use a calculator for that. Let's try an example then. So this is the binomial theorem. This is to get a general term. So if we are expanding x plus y to the power of 5, well, we know we're going to have these binomial coefficients. Because it is to the power of 5, we know the binomial coefficients would start off with 5, 0, then be 5, 1, then 5, 2, then 5, 3, then 5, 4, going all the way up to 5, 5. To get each of the entries, we have x to the power of n minus r. X is whatever is first in the brackets, and y is whatever is second. Notice here, whatever is first is just x. So we are going to have x to the power of n take away r, so that'd be 5 take away 0, which would just be 5. In the next entry, we would have x to the power of, well, we know the powers of x are going to be descending from 5 all the way down to 0, but we can also do x to the power of n take away r, which would be 5 take away 1, which is 4. We would have here x to the power of 5 take away 2, which is 3, x to the power of 5 take away 3, so x squared, x to the power of 5 take away 4, which is 1, and x to the power of 5 take away 5, which is 0. Whatever is second in the brackets, in this case it is y, that is going to be y to the power of r. R is just the number that's at the bottom here, so we'll have y to the power of 0, then y to the power of 1, at the bottom here is a 2, so it's y to the power of 2, then at the bottom here is a 3, so it's y cubed, then y to the power of 4, and y to the power of 5. Notice the powers once again, because we have x plus y to the power of 5, the powers here add to 5, the powers here add to 5, here they add to 5, right the way along, the powers will add to 5. Working that out then, 5, 0. Remember, if the power is small, use Pascal's triangle. So Pascal's triangle, you start with a triangle of 1s. The next row, you would have 1, 2, 1. To get this entry here, you just add the 2 numbers above. To get the next row, you're starting with a 1. 1 add 2 is 3. 2 add 1 is 3. And we're finishing with a 1. The next row, we will then have 1, 4, 6, 4, 1. And then 1, 5, 10, 10, 5, 1. So we know then 5, 0 will be 1. 5, 1 will be 5, 5 choose 2 is 10, 5 choose 3 is 10, 5 choose 4 is 5, and 5 choose 5 is 1. These are the binomial coefficients. Working that out then, 5 choose 0 is 1, we've got an x to the power of 5, y to the power of 0, which just becomes x to the power of 5. Here 5 choose 1, so the fifth row, one entry in, was 5, so that's 5, we've got an x to the power of 4, y to the power of 1, which we can just really leave as that. 5 choose 2 was 10. That would be an x to the power of 3, y to the power of 2. 10, x squared, y cubed would just stay as it is. The next entry is, well, 5x to the power of 1, y to the power of 4. We could just write as that. And here, 5 choose 5, finishing off with a 1. X to the power of 0, well, anything to the power of 0 is 1. So that becomes 1 times y to the power of 5, which we just write as y to the power of 5. Example 2, expand 2x plus 3y to the power of 4. We know to do that we are using the binomial theorem and looking at the different terms to get a certain term. X plus y to the power of n is n choose r, x to the power of n minus r, y to the power of r. Notice here x is whatever is first in the brackets. Here we have a 2x, that is first, so that will really be the value of x if you're expanding it. And the thing that is second in the brackets, which we're calling y, well in this case it's 3y. The binomial coefficients, because we have something plus something to the power of 4, we're going to have n as 4. And the first entry will always be 4 choose, you got it, 0. The next, well, all we're doing is we're starting with 0 and we're going up to 4 choose 4. So after 4 choose 0, we've got 4 choose 1, then 4 choose 2, then 4 choose 3, then 4 choose 4. Woo! The next part, we have x to the power of n minus r. X is whatever is first in the brackets. In this case, it's a 2x. So we're going to have 2x to the power of n minus r will be 4 take away 0. So we have 2x to the power of, that works out to be 4. The bit that is second in the brackets, y, in this case is 3y, that will be to the power of 0, but anything to the power of 0 is 1. Perfect, so we don't need to write that. After that, with 4, 1, we have whatever is first in the brackets, in this case it's 2x, so we'll have 2x to the power of n minus r will be 4 take away 1, which is 3. We have y to the power of r, so we have 3y to the power of, r is 1, so it's 3y to the power of 1. Next part, we have x to the power of n minus r. In this case, it will be 2x to the power of 4 take away 2, which is going to be 2. We have y to the power of r, so it will be 3y to the power of 2. After that, well, x still is the 2x, so we've got 2x to the power of n minus r will be 4 take away 3, which is 1. Y to the power of r will be 3y to the power of 3. 4 choose 4, well, we've got x to the power of 4 take away 4 is 0. That just becomes 1. You don't really need to write that. Y to the power of r will be 3y all to the power of 4. If we work that out then, 4 choose 0, 4 choose 1, 4 choose 2, just think about Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So, 4 choose 0, we're starting off with 1. 2x to the power of 4, well, to work that out, do 2 to the power of 4, 2 times 2 times 2 times 2, which is 16. X to the power of 4 will just stay as x to the power of 4. After that, we are adding on 4 choose 1, so we've got 1, then we've got 4, so that will be 4. We have 2x to the power of 3. 2 to the power of 3, 2 times 2 times 2 is 8. And the x cubed as well will be x cubed. 3y will just have to stay as 3y, so we're multiplying them together. Dot just means times. We are adding on 4 choose 2. Well, that's going to be 6. So we'd have 6 times 2x squared. Well, if we square the 2, square the x, we end up with 4x squared. 3y all squared, square the 3, square the y, and that's 9y squared. 4 choose 3, so that's 4, 0, 4, 1, 4, 2, 4, 3, so that's going to be 4. We have 2x, that's just staying, nothing's happening with that. And we're multiplying that by 3y to the power of 3. 3 to the power of 3 is 27. Y to the power of 3 just stays as y to the power of 3. 4 choose 4, well, that's the last entry here, that's going to be 1. 3y to the power of 4, 3 to the power of 4 gives you 81, and y to the power of 4 would stay as y to the power of 4. If you go through this and tidy it up, well, because we're multiplying by 1, we don't need to write that, so that's 16x to the power of 4. 4 times 8 times 3 is 96. We've still got an x to the power of 3 and a y. 6 times 4 times 9 is 216. We've got an x squared and a y squared. 4 times 2 times 27 is also 216. That leaves us with an x and a y cubed. And 81 times 1 is obviously 81. And we've got y to the power of 4. And that is what you get if you expand 2x plus 3y to the power of 4. Example 3. This time, expand 1 take away 4x all to the power of 3. However, dun, 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 what you notice with this one is there is a negative. Woo! So with the negative, you also have to include that when you're expanding. So each of the terms, well, remember x plus y to the power of n is n choose r, x to the power of n minus r, y to the power of r. Here, the value of n is 3. So when we are expanding that, we are going to start with 3 choose 0. Then we will have 3 choose 1, 3 choose 2, and then 3 choose 3. X is whatever is first in the brackets. In this case, it is a 1, which means then that we are going to have 1 to the power of n minus r. So it'll be 1 to the power of 3 take away 0, which is 3. 1 to the power of n take away r, 3 take away 1, which is 2. 1 to the power of 3 take away 2, which is 1 to the power of 1. And then 1 to the power of 3 take away 3, which is 1 to the power of 0. After that, y is whatever is second in the brackets. In this case, it is negative. Note the negative. Negative 4x. So we're going to have negative 4x to the power of, well, r. R is just the number at the bottom. So we have negative 4x to the power of 0. Then negative 4x to the power of 1. Negative 4x to the power of 2. And negative 4x to the power of 3. Working that out, to find the binomial coefficients, we just go to the side and we write down Pascal's triangle. 1, 1, 1, then 1, 2, 1, 1, 3, 3, 1. So these entries here will be 1, then 3, then 3, then 1. which means then we will end up with 1 times 1 to the power of 3 is just 1. Anything to the power of 0 is also 1. 3, 1 was 3, just from Pascal's triangle. 1 squared is 1. Negative 4x to the power of 1 is just negative 4x. 3 choose 2 is also 3. 1 to the power of 1 is just 1. Negative 4x squared will give us negative 4 squared, which is negative 4 times negative 4, which is 16. And x squared is just x squared. 3 choose 3, that's also 1. 1 to the power of 0 is 1. And negative 4x in brackets to the power of 3. Well, negative 4 to the power of 3 will give us negative 64. And x to the power of 3 is just x cubed. Tidy that up. 1 times 1 times 1 is obviously 1. That will give us here, if we bring the negative to the front, negative 12x. That gives us plus 48x squared, and then take away 64x cubed. And that will be your answer. Example 4, expand half x, take away y to the power of 3. Once again, dun, 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 there is a negative, so that has to come into play. Once again, we have the power of 3, which means each term is going to be, well, n is 3, so we are going to have for the binomial coefficients 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. X is whatever is first. In the brackets here we have half x, which means then that x here will be a half x, so we'd have a half x to the power of n take away r, so a half x to the power of 3 take away 0 is a half x cubed. Then over here we'll have a half x to the power of 3 take away 1, which is 2. Then a half x to the power of 3 take away 2, which is 1. And then a half x to the power of 3 take away 3, which is 0. Y is whatever is second in the brackets. The thing that is second in the brackets here is negative y. So we are going to have, note the negative, so we're going to have negative y to the power of, and then you're just taking this number at the bottom in the binomial coefficient. So negative y to the power of 0, negative y to the power of 1, negative y to the power of 2, and negative y to the power of 3. To work that out, again, we're going to use Pascal's triangle. So, because it is 3, we go down to the row which starts 1, 3. So we've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, meaning then these binomial coefficients will be 1, 3, 3, and 1. So 3 choose 0 is 1. The rest of that row will become a half x all to the power of 3. Well, if you cube a half, cube the number at the top, which stays as 1, cube the number at the bottom, which goes to 8, and x cubed will go to x cubed. Because this is to the power of 0, that just means it's going to be 1, so we don't really need to write it. 3 choose 1 was 3. A half x in brackets squared, well, a half times a half is a quarter, and then we've got an x squared. Negative y to the power of 1 is negative y. Here, 3 choose 2 is 3. A half x to the power of 1 will just stay as a half x. We don't really need to write this 1. Negative y squared will be negative y times negative y, which is y squared. 3 choose 3 was 1. A half x to the power of 0. Well, anything to the power of 0 is just going to be 1. And then negative y to the power of 3 is negative y times negative y times negative y. Well, that will give us a y cubed. But also, if you square a negative, it becomes positive. Multiply that by another negative, it stays as a negative. Tidy that up. An 8th x cubed times 1 will just stay as an 8th x cubed. If you have 3 times a quarter, that's 3 quarters. You've got x squared as well. You've got the negative y. Bring the negative to the front. Woo! And that gives you, take away, 3 quarters x squared y. 3 times a half is 3 over 2. X to the power of 1 is x, and we've got a y squared. And bring the negative to the front here, and we're taking away the y cubed. And that will be your answer. Woo! High five. Well done. Example 5, expand 3x, take away 2 over x squared, all to the power of 4. Once again, we have a negative. When you have a negative, you really have to pay close attention and make sure you use that negative for this y part. We have 3x take away 2 over x squared to the power of 4. So because we have to the power of 4, each of the terms then, n is going to be 4. So we will start with 4, 0 for the binomial coefficient. Then we will have 4, 1. then 4, 2, then 4, 3, then 4, 4, and after that we've got x plus y. X is whatever is first in the brackets. Here the thing that is first is a 3x. So we will have 3x to the power of n take away r, which is 4 take away 0. So we'll have 3x to the power of 4. Then we will have 4 3x to the power of 4 take away 1, which will be 3x to the power of 3. Then 3x to the power of 4 take away 2, which will give us a 3x squared. Then 3x to the power of 4 take away 3, which is 3x to the power of 1. Don't need to write the 1. And then 3x to the power of 4 take away 4, which is 3x to the power of 0. Again, you don't need to write that because it's to the power of 0. You know it's going to be 1. Y is the thing that is second in the brackets, and it's y to the power of r. Here, the bit that's second in the brackets is the negative 2 over x squared. That, therefore, will be the value of y, if you think about it. So we're going to have that to the power of r. R is the number at the bottom in the binomial coefficients. So we will have negative 2 over x squared to the power of 0. Then negative 2 over x squared to the power of 1, then to the power of 2, then to the power of 3, and finishing with the power of 4. To get the entries for the binomial coefficients, we write down Pascal's triangle: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Woo! If you sub them in then, 4, 0 was 1, 3x to the power of 4, well 3 to the power of 4 is 81, x to the power of 4 stays as that. Because this is to the power of 0, anything to the power of 0 is 1, so that will disappear. 4 choose 1 is 4, 3x all to the power of 3, 3 to the power of 3 is 27, x to the power of 3 is just x to the power of 3. We have this negative 2 over x squared to the power of 1, so it's just negative 2 over x squared. 4 choose 2, well that's 4 choose 0, 4 choose 1, 4 choose 2, so that is 6. So it's 6 times 3x all squared. 3 squared is 9, x squared is just x squared, and negative 2 over x squared, we'll take the negative with the 2, negative 2 squared is positive 4, and x squared all squared will be x to the power of 4. 4 choose 3 is 4. 3x to the power of 1 is just 3x, and negative 2 over x squared all to the power of 3, well again, take the negative with the 2. Negative 2 to the power of 3 will give you negative 8, so we've still got the negative, and x squared to the power of 3, just times them together, and you'd have x to the power of 6. 4 choose 4, well that's just going to be 1. 3x all to the power of 0, well, anything to the power of 0 is just 1, so really you've got a 1 times a 1. And then you've got this negative 2 over x squared all to the power of 4. Negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2, which works out to be 16. And we've got this x squared to the power of 4 times them together, and you get x to the power of 8. Tidy that up once again, that gives you 81x to the power of 4. We've got the negative, so bring that to the front. And then 4 times 27 times 2 is 216. And x cubed, well, we're then dividing that by x squared, so that'll leave us with an x. 6 times 9 times 4 is 216. We've got an x squared, and we're then dividing it by an x to the power of 4. So, when it's the same base, subtract the indices. 2 take away 4 is negative 2. So I have an x to the power of negative 2, which is the same as over x squared. Or you can cancel out the x squared here, cancel out 2 of these, and it leaves you just with an x squared on the bottom. We've got a negative here, bring the negative to the front. And that gives you the negative. 4 times 3 times 8 is 96. And x over x to the power of 6, cancel an x there, cancel one of these x's, and it'll leave you with an x to the power of 5 on the bottom. Or x to the power of 1 divided by x to the power of 6. Same base, subtract the indices, so you get x to the power of negative 5, which means you can move that to the bottom, so it's still x to the power of 5. And here, 1 times, well that's just going to stay as it is, 16 over x to the power of 8. So that would be what you get if you expand this. Example 6, slightly different this one. Use binomial theorem to find 1.04 cubed. Well, to do this, we know the binomial theorem is used when we have something plus something to the power of n. We can see here that it's to the power of 3. So, we want to find a different way of writing 1.04. We want to find a way that is easy to expand. And what we could think about is, right, well, if we use the number 1, well, that'll make it quite easy because we'd have a 1 to the power of something, 1 to the power of something else, and so on, and that's easy to work out. So let's write it as 1 plus, and then what do you add on to 1 to get 1.04? Well, you obviously add on 0.04. So we can write 1.04 as 1 plus 1.04, and that gives us the something plus something to the power of something else in order to use the binomial theorem. So because we've got something to the power of 3, we know that the general term here tells us we've got nr, and n is going to be 3. So the entries we will have, the binomial coefficients, 3, 0, then 3, 1, then 3, 2, then 3, 3. We have x to the power of n minus r. X, remember, is whatever is first in your brackets. In this case, it is 1. So we're going to have 1 to the power of n take away r, so 3 take away 0, so it's 1 cubed. Next, we will have 1 to the power of 3 take away 1, which is 2. Then 1 to the power of 3 take away 2, which is 1. And then 1 to the power of 3 take away 3, which is 0. Y is whatever is second in the brackets, but the number that is second in the brackets here is 0.04. So we are going to have 0.04 to the power of r. Remember, r is just the number at the bottom of this binomial coefficient. So we'd have 0.04 to the power of 0, then 0.04 to the power of 1, 0.04 to the power of 2, and then 0.04 to the power of, well, at the bottom here we've got a 3, so that'll be to the power of 3. To work that out then, 3 choose 0, use Pascal's triangle. So we have 1, 1, 1, then 1, 2, 1, 1, 3, 3, 1. So the entries here, 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3 are the numbers 1, 3, 3, and 1. So we will have 1 times 1 to the power of 3 is obviously 1, 0.04 to the power of 0. Well, anything to the power of 0 is just 1. This here, 3 choose 1 is 3, that's staying as 1, and that would just stay as 0.04. 3 choose 2 is also 3. 1 to the power of 1 is 1. And then 0.04 squared, well, if you multiply that by itself, you get 0.0016. 3 choose 3 is 1. 1 to the power of 0, anything to the power of 0 is also 1. And 0.04, if you cube that, you get 0.000064. Meaning then, if you tidy that up, well, that's just going to be 1. That becomes 0.12. This here becomes 0.0048. And this number, well, if you're multiplying it by 1, it would just stay as it is. Multiply all of them together, and you get 1.124864 for your answer. And you can always check if you're right by subbing that into the calculator. Put in 1.04, bump, 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 cube it, and you end up with that. Example 7, use the binomial theorem to find 0.7 to the power of 4. So to do this, again, the binomial theorem is dead easy to use if you've got easy numbers. So we want to try and pick some easy number. So we want something plus something. But an easy number to use would be 1. So what we can do is we can write down 1. And then what number would you add on to get 0.7? Well, you wouldn't be adding a number, you'd be taking away. So you are going to have a negative. And what number would you take away? 0.3! Perfect. So you can write 0.7 as 1 take away 0.3. And instead of having 0.7 to the power of 4, we'd have 1 take away 0.3 to the power of 4. Binomial theorem, each term n r, x to the power of n minus r, y to the power of r. So for each term, n is going to be 4. So we're going to start off with the binomial coefficients as 4, 0. Then 4 choose 1, then 4 choose 2, then 4 choose 3, and then 4 choose 4. X to the power of n minus r. X is whatever is first in the brackets. You can see that there. Here, first in the brackets, we have a 1. We chose 1 because that's dead easy to use, because we're going to have 1 to the power of 4, which is 4 take away 0, 1 to the power of 4 take away 1, which is 1 to the power of 3. Then we end up with 1 to the power of 2, 1 to the power of 1, and 1 to the power of 0. Y is whatever is second in the brackets. Well, the bit that is second here is negative 0.3. Make sure you include that negative. So we will have negative 0.3 to the power of 0, it's just the number at the bottom, then to the power of 1, then to the power of 2, then to the power of 3, and then to the power of 4. To work out these binomial coefficients, we use Pascal's triangle. This as it here, so we're starting off with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and to get the next row, start with a 1, 1 add 3 is 4, 3 add 3 is 6, 3 add 1 is 4, and we're finishing with a 1, which means these numbers here, the binomial coefficients will be 1, that's a 4, that's a 6, that's a 4, and that's a 1. So we end up with, we'll have 1 times, that becomes 1, that becomes 1 as well, because it's to the power of 0. That will be 4, that will stay as 1, and that's just negative 0.3. This here, well that was 6, so that's 6 times, that stays as 1. Negative 0.3 squared will be positive 0.09. This here, 4 choose 3 was 4, so that's 4 times, that's staying as 1. And negative 0.3 cubed will be negative 0.027. 4 choose 4, finishing off with a 1, so that's 1 times, anything to the power of 0 is 1. And negative 0.3 to the power of 4 will be positive 0.0081. Tidying that up slightly, you get 1 takeaway 1.2 plus 0.54 takeaway 0.108 plus 0.0081. And if you work that out, you end up with 0.2401. And again, to check if you're right when you're working through these, just fire that into the calculator, 0.7 to the power of 4, and that is what you will get. Woo! That is it for expanding x plus y to the power of n. Remember, you are using the binomial theorem to work out an individual term. Remember, you have nr, x to the power of n minus r, y to the power of r. Try these questions in the Unit 2 booklet, pages 5 and 6. Check your answers as you go. Best of luck, have fun, woo, bye.